Hey everyone, so in this video I'm going to show you how I set up my power feeder on my table saw. I had a viewer ask me about the power feeder and he was like, oh, that's cool, like what is it, all this kind of questions and stuff, and he suggested maybe I make a video on how to use it. So there's a lot of different ways you can use power feeders. This is the first time, it's kind of funny, this is the first time I've seen it used, and of course I'm the one who's using it on a table saw. Normally I see them on a shaper. Shapers often use very large bits, which are extremely scary, and you don't want your fingers anywhere near those things. So a power feeder, from a safety standpoint, is awesome on a shaper, but from a consistency standpoint, it's running it through at a nice consistent speed with pressure, so there's no burning or chipping or it's coming out or whatever. Power feeders are great for consistency as well as safety. But so here it is. It's set up on my table saw. So when I bought this table saw, it came with the power feeder, and I was like, oh, that's pretty cool. Like, yeah, I'll take the power feeder too. Like, I know it's pretty efficient. And so like when you're using the table saw for like, whatever, you're making a small project, I don't normally have it on the table saw. I can't just keep it on there. It gets in the way of the fence. So I normally keep it stored on a little cart right here, which happens to be the same height as the table, so I can just kind of wheel it over. It's a very heavy machine. So, but once you get it bolted on, it's bolted on with 1/2-inch bolts, so they're pretty durable. It's a pretty stiff setup, so it doesn't move, even though the arm is cantilevered out quite a bit. It's a pretty stiff setup. So, but I've never seen it on a table saw before, and you normally wouldn't use it on a table saw if you're making one cuts here and there, and you gotta always move the fence because you're making different widths. It's not really efficient for that. But if you're making a bunch of pieces all the same width, for example, I'm making a whole bunch of cornhole boards right now. I need to make a bunch of 2.5-inch wide strips out of each of these pieces. Then from an efficiency standpoint and from a safety standpoint, from a fatigue standpoint, and from an accuracy standpoint, it's nice to have the power feeder. So that's what I'm using it for today. Making a bunch of cornhole boards right now. So in fact, that's the only thing I've ever used it for, is for that, because that's the only thing I really make a lot of at once. Other than that, it's usually a bunch of one-off stuff with different measurements, so it's just not conducive for that. So anyway, this is it. So I have a 3-phase setup. It's a 3-phase motor. So I have my 10 horsepower three-phase inverter down here. So and that feeds the outlet right there up on the wall. It has two motor adjustments, or two speed adjustments on here, or maybe I should say 3 total or whatever. First of all, it can run in 2 different directions. And right up top here, you're going to notice that there's 1, 1, and 2, 2. So the pointer is here. Depending on if you're on this side, you're running forward. If you're on these numbers up here, you're running in reverse. So you wouldn't necessarily do that on the table saw, but on a shaper, you might be running it in a climb cutting fashion. So that's why you'd want to run it in reverse. Versus running in the conventional direction. And then the numbers stand for, this is a slower speed. The motor will spin at a slower speed. The motor will spin at a faster speed. So obviously 2 different speed rates. And then you got this lever down here, which has 2 speed controls on it. Right now it's on number 2, and then you can switch it over to number 1. And then 0 in the middle just means it's not connected at all. And this is gears. So the nice thing about having 2 different settings is that you can set this at a slower speed gear-wise, but you can have the motor spinning at a fast speed. That means it's going to give you a lot more power for pushing through. And in this case, you don't really need the power on the table saw, but again, on a shaper, you might need power to push your piece through. So you'd want a lower gear setting with a higher, a faster motor speed. That is going to give you more power, more torque, right? And then, but if you're looking for, I mean, it's powerful either way, but if you're looking for just overall speed, so on the table saw, you're able to crank this up. I actually have this set as fast as it'll go, because a table saw blade is a little 1/8-inch blade. So it's not really cutting, it's not a lot of friction, there's not a lot of pushback. So you can very easily run this through as fast as it'll go, and it won't bind up, and it won't bog down. So that's where I have it set right now. So for me, for cutting 3/4 inch birch plywood, I have it set at speed 2, which is the faster gear setting, and I'm going to turn it on at motor speed number 2, and that's as fast as it'll go. So let's see what it looks like. I'm going to turn my inverter on and flip the switch. All right, you can see all 3 wheels are going. They are rubber wheels and they're spring loaded. So I'll talk about that. Shut this off. So the rubber wheels are tires. The rubber is going to be for grip. So you want that rubber to actually grab the wood because it's just a smooth surface. But if it's rubber, then obviously rubber has some grip, and that's what pulls the board. Pushes the board / pulls the board through. So I have, for setup right now, you can see the table saw blade is down right here. I have the blade in between these two. So for the most part, I want more power in front of the blade pushing the stock through. So I have 2 wheels in front of the blade, 1 wheel on the opposite side. Now you can buy power feeders with 4 wheels, and then I guess you could do 50-50 if you wanted. But in this case, I want more power pushing through, and as it exits the cut, it's not really as important. So you only have 1 wheel pulling / pushing the stock out the rest of the way. So I also mentioned that they're spring loaded. So how this works is it's putting pressure down on the piece. So if it's a 3/4 inch piece that I'm sending through, I don't want to set the bottom of the wheel or the tire, I don't want to set that 3/4 of an inch up off the table, because then there won't be enough pressure pushing down on it and it's just going to spin and slip. So I left myself a little note up here. Might be hard to read, but for 3/4 inch plywood, I have it set to either 1/8 to 1/4 of an inch below the top of the wood. So I usually split the difference at, we call it 3/16. So you take 3/4 minus 3/16 and you end up with 9/16. So I did a measurement before I set the fence up. So at the bottom of the tire is 9/16 above the surface of the table saw. So the wheels are spring loaded. So the springs are pretty heavy duty. Like, I can't compress those springs with my hand. But as you send your piece of wood through, the wheels, the tires are going to move up. That spring pressure is going to be pushing down against it. This whole arm is nice and rigid. Everything's super, overbuilt and cast and all that kind of stuff. So it's not like the machine is going to warp out of place. I mean, there's a little bit of play, because there's always going to be a little bit of play, but it's really not that much at all. And it puts pressure down on it. Now, when I do a cut in just a few minutes here, you may notice that I have a little bit of slipping going on. And there's 2 reasons why your piece might slip or get stuck and just stop moving. 3 reasons. One reason could be that it's too much friction pushing back from the blade, and that could be because your blade is dull and it's just binding up too much. So make sure you have a nice sharp blade on. The surface of your table saw might not be smooth enough. I just put a fresh wax on this so that you can kind of see how shiny it is. So it's nice and waxed, it's nice and smooth and slippery, so that there's no friction against the wood. And then my problem that I'm having right now is that these tires are getting pretty old, and I really need to replace them. So the rubber is getting kind of hard, and then mixed with a little bit of sawdust that gets on there, they tend to get a little slippery. So, and I don't know if you can see, there's a groove right here. Yeah, I may or may not have, when I first got this, had some learning curve errors, and didn't have all this assembly tightened down as much as I thought I did, and I ran the tires into the blade. Fortunately, if you do that, the nice thing is it is rubber. So you're not really going to destroy anything too much, because the blade's going to obviously cut into rubber fairly easily, or very easily. I shouldn't even say fairly, very easily. So, and it is only just a single groove, so I still have a lot of surface area to send the boards through. So not a huge mistake there. But the last piece of setup is, once you have your fence set, in my case it's 2.5 inches away from the blade. I got it set right here. You're going to notice, if the video will show it, there's a slight angle to the actual power feeder itself. So it is not parallel to the fence. You do not want to have it parallel to the fence. You want to have it slightly out of parallel in the direction towards the fence. All right, it is kind of hard to see in the video, but it does have a slight angle. And that is just like you're using on a push stick. When you're sending a board through, I mean, you can go parallel to the fence, but I tend to have a little bit of an angle towards the fence with my push stick. That way my pressure is going against the fence for accuracy reasons, and then obviously for safety reasons, you don't want to be going towards the blade, because then that's when kickback happens. So in this case, yeah, and it's a huge accuracy thing. You want to have it always constantly pushing against the fence, keeping that 2.5-inch measurement consistent for every single piece that you send through. So that's a really important piece of setup, and that can be adjusted right here. It can be adjusted here, actually even better adjusted right at the motor itself, because then it just pivots right underneath the motor there. So a lot of adjustments. You have a pivot adjustment here. You have another pivot adjustment here. You have an adjustment here that actually rotates it, because you do want your tires to be parallel to the table. So make sure that you're measuring front and back. Once that is set, that's pretty much a set it and forget it. I mean, you can always double check to make sure it's not out of adjustment, but it should be pretty well set. And then you have this does not rotate back and forth. All this does is loosen up a clamp so that you can raise and lower. And then this clamp, once you loosen it up, you can slide it in and out. So a lot of adjustment on it, so it's a pretty sweet setup. Yeah, man, so that's pretty much it as far as setup. I'm going to run a piece through. I'll show you what it looks like. I'll set up a tripod here and run a couple of pieces through, and you can see that it's really nice. It doesn't go through, I wouldn't say the speed is very fast. I don't think you're saving a ton of time because of the speed, but it is nice and efficient, because you'll be able to see how I'm walking back and forth, and I'm constant. It's like sending something through the surface planer. But the other thing that's really nice about it is my fingers are not at the blade. And then I'm just kind of feeding the piece in and letting it go, and it's doing its thing. So from like a strength standpoint, a couple of pieces not a big deal, but if you're doing it the whole time, it's just, it wears you out, right? So this is doing all the work for you. So it's a little less, it's a lot of stress off your hands, especially as you get a little bit older. You don't want your hands cramping up because you're doing the same thing over and over and over again. So, all right, let's send the board through. And so there you have it. That makes pretty short work of that. As you can see, I wasn't putting in any effort other than sliding the board into the power feeder, just like you would a surface planer. So really not much effort there. And every piece now is exactly 2.5 inches wide with pretty minimal effort. So that's it. Hopefully you learned something there. Pretty cool machine. They're not the cheapest thing in the world, but if you're going to get some use out of it, I bought this used, so it was kind of like an easy sell on me. And honestly, when I bought it, I was like, oh, I don't know, this is pretty cool. It's coming with the table saw. It's kind of a package deal. So I'll just take it. I'm sure I'll use it someday, and if I really don't use it, I can just sell it, because I know they're a popular machine to have. In fact, my buddy was just like, well, the second you don't want it, I'll buy it from you. But anyway, now that I'm making a bunch of cornhole boards, it comes in handy to fire a bunch of pieces through. So yeah, so that's the power feeder. Hopefully you like it. Any questions, let me know. See ya.